I'm going to go over interfaces today in Unreal Engine. So right here, we had this game plan. We have this character. He's going to throw a cubic cube, and what's going to happen is awesome little items are going to come down and interact with that. So we want to throw an object, right? So we have before a rock you could throw. So you could have this rock, and then the rock would do an animation, and at the arc of the throw, we'll see we'll just play real quick. We have this throw, and you can see now I just removed it, so this is not going to work. Let's go back to where it was. So I could have this code, and what you'll notice, we have a throw animation. This throw animation, in the middle of the throw, when there's about to release, you can see it has an animation notify. And in that animation notify, what's going down is it's saying, hey, I know the actor. Get all the attached components to that actor. And if one of them is a rock, go ahead and throw it, right? So I could have this code here. I could cast to this rock. It's already casting to that. I could just go to this rock, and if it casts the rock successfully, go ahead and throw this object, right? And then the rock has some special knowledge. So I have this object, I have a rock, and yay, look, I can throw the rock, I can bounce it off the ground, yay, success. And it releases at the peak of the throw, so it looks really good for the animation. Yay! So, now what happens when I want this cubic cube to fly through the air, right? Now, all of a sudden, I'll have to check for that object. So I could, for instance, right in here, I could say, hey, let's go ahead and cast, maybe it's not a rock, maybe I want to cast it to the cubic actor, right? And if it's the cubic actor, it can throw. Or, for instance, the cubic actor could inherit from rock, and so this function could be virtual, this release throw, right? And it can interact in the same way as the rock, inherit from the rock. But maybe we don't want to inherit from the rock, right? Maybe instead of flying through the air like we would expect, this rock instead, it's a missile. Or in this case, it's this cubic actor and it has some other logic, and it's not good to inherit from this actor rock. So this is where an interface can come in. So an interface allows you to take any object, for instance, any attack toucher, and you can just tell it, hey, could you throw this interface? Can you try to attempt to do this interface, right? And so if the actor cannot do the interface, this will do nothing. Now, one thing you can also do is you can just check. You don't have to. I could do two things here. I could check, hey, does this actor implement the interface? But at the same time, I don't even need a check. I could just, any single actor that's attached, hey, go ahead and try to throw. Throw it. Why not? And so this actor, if we go to the class settings here with the implemented interfaces, I can add the interface to be able to throw, right? So you can now throw this actor, and you see how it popped up right here. It's this little event, throw, and it just goes to here. And hey, that's perfect. And I might as well just say, well, I can now, could you release the throw? I'm going to go call that function. So it's going to call this function right above, and it's going to go ahead and release the throw. So you might think that's a little bit roundabout, but in fact it's not, because now anything can implement the event throw, and if it's attached, it will work with it. So we have this rock, and now when this animation goes off, it's just going to throw any object that it has attached to it. So we play from here, and I have the object, and look, I get to throw the rock, and that interface works. So one of the things that I also really like to do is I like to define my interfaces in C++. Now the reason is this can totally be created in C#. You can just right click here, you can just type interface, and then you can make a blueprint interface. Yep, fantastic. Now and if you only work in blueprint, why not? But it's not hard to define it in C++. And the benefit to that is now any actor in C++ can call this, because you have to remember, in C++ it has no idea about blueprints. Those are completely invisible to it. So here's me. I'm just inheriting from a U object, right? Just saying, hey, look, this is my basic U object. I'm going to make this interface. I'm going to make it blueprintable. You can also ask ChatGPT for do this for you, and it will do it perfectly, no problem. And then what I'm doing here is you first define the class of the interface, which is inherited from the U interface. That's basically just left blank. And then below it, you'll go ahead and say class. This is just a namespace that is for our game. We're inheriting from the library game. And then I want to throw the interface. There's a little generated body. This is all C++ classes in Unreal have that. And then again, I just define this public, and then I can say, hey, look, I want to make this blueprint callable, make this a blueprint native event. So the objective here is that blueprints are going to implement this. Now, you don't have to have this implemented by a blueprint. A C++ could inherit this, and it could implement a throw implementation, and it could run the same exact code or interact with it. Now, and you can also have some object, right, call and say, hey, object, if you have this interface, go ahead and run it. And then so you could have a blueprint throw its weapon, right? Because that notify, right, maybe I don't want that notify as a blueprint. And so that really expands. I usually keep all my interfaces just in a little spot here, and they do all sorts of things. But it's really good to just define them really simply like this. Again, ChatGPT can do it for you very easily. And now you have an interface where I just showed you, you can go ahead and implement it right in the actor, and now it's some really clean code. Now I'm just going to add this, even though I really don't need to. I don't really have to be checking and branching. I could just be throwing on any single object regardless if it's the type of object, and I don't have to cast, because one thing to remember is when you cast to an object, you are in fact adding that to the size map. So now if I were to go to this animation notify, wherever this animation notify uses, if you look at this size map, you'll see that it has, due to referencing the BP rock, it now, that's weird. Is it because this rock doesn't know? It should have its material. Standard macro, self, throw. Am I looking at the right one? Animation throw. Oh no, I need to recompile and save. There it is. All right. I was wondering. I'm like, why? See, this is what it would look like when you are not casting. But now that I'm, when you are casting, right? It's just a really small 450 kilobyte actor. Now that I've compiled and saved the fact that we are casting to this BP rock, and maybe we're casting to this cubic thing, if I were to right click on here and I would look at the size map, boom, you can see it's 149 megabytes. So whenever an animation is throwing, now it wants to do that animation. This is all put into it. And so when you load that animation, you're loading all of this information. You're loading the rock, you're loading this static mesh, and this can get really big really quickly if you're not using interfaces. So just one of the cool things we can do, right, and go from 149 megabits to, and I'm just going to go ahead and delete these casts and just run straight to throwing the rock. And now we can take a look again, all the way back down to 453 kilobytes. All right.